I'll have it for later. All right, cool. So welcome everyone to Acing Your Technical Interview with SWE and ACM. Um, Here's just like an overview of like what we're gonna do today. So we're gonna talk about we're gonna give you an overview of interviews, we're gonna break them down, and then we're gonna actually do a live mock interview to show you what you can expect. And for introductions, I'll start. My name is Katie. I'm a CS major. I'm here representing SWE, but I'm actually also an ACM officer, so I'm kind of representing both, I guess. But I'm also an intern at State Farm. So that was my first internship, which I got through a technical interview. So last year's my first experience with technical interviews. But then this year I've actually done 11 so far. I just counted them up. And some of those are with like the same companies, but it's definitely been a lot of interviewing this semester for me. So I've learned a lot and I really want to share that with you guys. And yeah, probably interning at Bloomberg next summer.
So, hey guys, I'm here representing ACM today. I'm also a CS major, and some of my interests include ethical AI and ethical hacking. And I also really like security, specifically network security. My background is I am an ACM education officer, and I used to intern at T-Mobile as an explorer intern in identity and access management. I was a Cisco security consulting engineer intern this past summer, and next summer I'm gonna be a Amazon SDE intern. So I'm excited to see if it's gonna be in person because we can all go to our internships in person.
Wow, what a flex. Okay.
No.
So yeah, we're gonna start with the overview. Oh wait, this is me. Okay. So what is a technical interview? I'm sure you've heard about this a lot if you're a CS major or CE major, but this is because companies want to see your technical experience. With a lot of fields, it's really hard to kind of see those concrete skills in action, but with like computer science, it's really easy for companies to test your skills. So that's why they do it. So this is going to differ from the behavioral interview, which is going to be more of the traditional interview people think of, where they ask you, what's your biggest weakness and things like that. But this is the technical interview. So this is where you need to show off your skills and show that you can do the job. These are usually conducted by engineers at the company and not, HR or people without a technical background, which means you typically need to know your stuff because they're going to be able to tell if you don't because they have the same experience as you. One thing that technical interviews are not is they're not tests to see if you're the perfect programmer. You don't have to be some competitive programmer who knows, every single like library and can implement everything immediately. Companies more so want to see how you work to approach difficult problems and problems that you might see in the internship or in the job. And they also kind of want to see, are you someone they'd want to work with? It's not just about, again, your technical skills, it's also about how you can kind of work with the interviewer to solve this problem. Again, a lot of these engineers might be the engineers who work with you at the company. So they want to see, do I want this person as a coworker? They also want to see that you're good at communicating your thought process with others. This is a really important skill for interns and for people in the industry, being able to break down a problem and explain your thought process. Because if you're given a problem and you can't talk about it and explain like what you're having problems with and things like that, that really won't make you a good employee. They want people who are going to be able to work with other people to solve problems. Another cool thing about technical interviews is that you get to talk to engineers at the company. And every interview I've been in, at the end, they've given you the opportunity to ask questions about the company, which has always been really helpful for me because I've gotten to learn about the company from someone who actually works there in the position that I'm interviewing for. But there are actually different types of technical interviews. Today, we're going to be focusing on the coding interview, but I'll also give a brief overview of the others. But the coding interview is what's going to focus on your knowledge of data structures and algorithms. Um, Obviously, like that's a class everyone has to take in CS, right? But even if you haven't necessarily taken that class yet, it's still possible to pass technical interviews. I know I was able to pass my State Farm one last year, and I'm currently in data structures, but I've still been able to do interviews. So if you haven't taken that class yet, like don't worry, you can still learn how to do well in these interviews. But that's typically like what they focus on. And there are different formats you'll see. The most common one is going to be the phone interview, and that's kind of what we're going to do a mock version of at the end. So in this type of interview, you're going to open a shared editor with the engineer who's interviewing you and work through problems in that editor. So you're going to have, it's kind of like Google, if you think of Google Docs where people are editing the same document at the same time, it's kind of something like that. So you share an IDE and they'll give you a problem and you'll code it right there with them. And some companies expect like working compilable code. Some companies just like turn off the compiler and they only want to see your thought process. So that will vary as well. And then the other major type of coding interview won't actually involve any kind of typing. It's literally whiteboard coding. Obviously, in today's environment, that's a lot less common because we don't have any in-person interviews happening. But once in-person interviews are back, you can definitely expect to see lots of whiteboard coding where you go in the interview room, there's a big whiteboard, and they'll give you the problem, and you literally have to like write out the code on the board, which can be definitely like pretty intimidating because we're so used to coding by just typing it out. So it's definitely a skill that you have to learn, but luckily for you guys, that's not happening this internship season. So you don't need to be too worried about that happening. But it's definitely a good skill to be able to write code without an IDE and without a compiler and to just be able to write that syntax out. And with whiteboard coding, they don't expect perfect syntax. It's more, again, seeing your thought process and how you approach problems. But I did mention there are other types of technical interviews. So I'm just going to briefly kind of go over these. But again, they're much less common. So one is just kind of more of a general technical interview where they don't actually do any coding and they ask you conceptual questions. And some interviews will be kind of a mix of coding and then questions like these. So these will be questions like explain what object-oriented programming is, explain how database normalization works, and things like that. If you're applying to like a really specific intern role, especially, you'll see questions like this. One example of a company that does this, from my experience this year, was JP Morgan. I know they do a lot of recruiting at UTD, so I'm sure a lot of you guys are like listening to that. But their interview, for me at least, didn't have any coding. It was like 45 minutes of them just asking me general questions. So not every technical interview involves coding, just the vast majority of them do. And then the other one is like system design. So these are questions where they ask you how to design a system, which sounds super vague, but these are going to be more common for like new grad roles and like full-time over internships. But I know I have had one of these this year, so I just wanted to like bring these up too. So these don't involve any coding, and like the one I had was design a URL shortener. So I had to spend an hour just talking through how I would approach designing a URL shortener from scratch. So we talked about things like database and like data structures that I would use, but never actually implemented those. So again, this just wanted to give you exposure to these other types of technical interviews that you might encounter, but we're going to focus on the coding interview today.
So the first thing you have to consider when you approach a technical interview is what language am I going to use? There's so many out there and all of them have their own merits, but specifically for data structures and algorithms, there's like some that are better than others. And the first thing we want to say is there is no best language. Every single language is created for a reason. It's because of flaws in one language that urged another software developer to say, hey, I want a language that specializes in this. I want a language that's best for my system. I want a language that does this, yada, yada, yada. So I'm going to give you guys some general tips, but keep in mind that these are no way, shape, or form, in no way, shape, or form, like definitely super strict. Like you can do whatever you want, depending on what you're comfortable with. So if you guys are out of time, choose the language that you're most comfortable with and get good at it. So if you have an interview in a week and you haven't been practicing data structures and algorithms and you already know Python, get good at Python, get good at data structures in Python, and you have the best shot at doing well in that interview. So if the job requires a certain language, but they give you a lot of choices in your coding interview or anything, it's your best bet to choose the language that they have in the job requirement so that they know you can do that language when you're hired. And this is also very good because if you do a very good job and another intern also, or another prospective intern does a very good job as well, they know who to choose. You obviously know that language already and you're comfortable in it because you can do an interview in it. And no matter what you choose, it's less about the language and more about your understanding of data structures and good coding practices. So it's putting those comments in, explaining yourself really well, getting the big O efficiently, making a good use of all of your variable names and things like that. And most of all, it's practice, practice, practice. You can always do well with more practice. There's nothing wrong in getting over practice. Like, just, it's always good to get that experience. The more you know, the better you'll do. So I'm going to give you guys three or four programming languages that are good, that are better for data structures and algorithms, and that are also like widely used, but these are not the only options. So the first one is Python. Python has a very clean syntax, and it's often coined that you can do something in 10 lines in Java, but it's only 1 line in Python. And it's very true. It has a very clean syntax, and it's really nice to look at. It's also easier to implement data structures in that sense. You're able to just write 1 line and some data structures will be written out for you. And if you want to go through some easy operations in some data structures, that can also just be 1 line of code, whereas it wouldn't be that in other languages. It's also very well known, and it's also super readable. So your engineer or interviewer, whoever's giving you this question, should be able to understand Python. It's one of those languages that you don't need to give extra clarification on. One of the cons that comes with the cleaner syntax is that it's harder to tell time complexity. So an O of n operation might look like an O of 1 because it's just taking up 1 line, but in actuality, it's O of n. So I know Katie really loves Python, so I'll let her say a couple of words about why she likes it and something she finds hard in the language.
Yeah. So I actually used to use Java for coding interviews, but I found myself like messing up the syntax a lot because there's always so much pressure when you're in an interview trying to type fast. So I actually like taught myself Python syntax. I never really used Python too much in the past, but like this summer I was like, let's see what Python, and like changed my life. I can do coding interviews so much faster now. It's great. Like to create a hash map in Python, it's literally like x equals and then 2 curly braces. Like in Java, I would have to write like hash map, integer, comma, integer equals new hash map, integer, comma. Like that's so much. Like just do Python. But Alarica can talk more about the benefits of Java. But again, I'm personally a Python person. Highly recommend.
So one thing I will say with Python is when you really need the speed after you have your good base and data structures, it's good to go with Python because some of these bigger coding interviews, you'll have 20 minutes to code out, like maybe a LeetCodeHard. And it's harder to use Java and C++ to like elaborate on all of your responses when you have 20 minutes to explain, type, do everything. So Python is easier in that sense, but for Java, there's a lot of support for data structures. So depending on every unique case, there's most likely a Java library already out there. Like you don't really have to do much in that sense. And Java is also always updating. So if you don't have a library now, chances are if enough engineers need it, there'll be a library in 1 year. And it's also easier to understand the algorithms because it's a little bit more spaced out. Everything's cleaner in the understanding sense. And it's also widely used. So similar to Python, you can expect your engineer or your interviewer to already understand what you're typing up. There should be no need for extra clarification or any misunderstandings in the language itself. One con is that it is a very verbose syntax. You have to write out a lot, and there's some places that you can mess up. But I personally am a little bit biased towards Java. I actually learned C++ for the whole year last year, and I thought I could actually be a C++ coder and do all my data structures and algorithms in C++, and I quickly realized I could not do that. So I switched to Java, and it helped me a lot. I don't see myself switching away from Java, but I definitely can see myself like exploring more in different languages. And C and C++. So one pro in this, and a reason why a lot of companies love C and C++ is because it results in faster algorithms. So in Java and in Python, because a lot of these data structures are already written out for you, there's some unnecessary overhead. And one example I will give for this is essentially hash tables in Java. And this comes with multi-threading and synchronization. It's one thing that you don't need in interviews. So this provides a lot of extra overhead that Java will do regardless of if you need it or not. So it's one thing when you use C and C++, you can control all of these different elements and have a better understanding of what exactly do I need for my program and only include those aspects. And you also have a better understanding of data structures as a result. C and C++ don't really have a lot of elaborate and pretty libraries like Python and Java. So you have to really know what you're doing and understand the algorithm and data structures better than a Java or a Python programmer. And it's also very well known. So along with Java and Python, C and C++ are languages that you should expect your interviewer to know about. One thing is it is slower to implement some of these data structures as a result of what I've stated before. And it also has a lot of gotchas. One thing I always hear from my C++ programmer friends is memory management issues. It doesn't have a garbage collector. You have to free up all of the memory yourself. And it really is a pain. So everything else, I see there's a lot of talk about assembly and Scratch in the chat. I mean, go ahead. If you can use assembly and make data structures in assembly, like, you are God. Please teach me how. But if none of these languages interest you, you can definitely choose another language. Just keep in mind that they are like fewer like engineers that are fluent in this language. So if it's not required for your job, you might need to be more elaborate in your explanations and also in your comments, and make sure you're just doing those coding practices. And additionally, there might not be a lot of support to learn them. So I would recommend learning data structures and algorithms in C, C++ or Java first, and then moving on to this third language, because when you go online and you try to look up an algorithm or a data structure, you're going to find out how to do it in Java, C, C++, most likely, and then Python, and then the rest of them. So if you're learning about the actual like functionalities and the abilities of the data structure, I wouldn't recommend going with any of these other languages. So approaching technical problems, this is a very big thing. As Katie mentioned at the beginning, it's not really the best solution that you want to get. It's the approach to your problem and how exactly you're thinking through these things. So here's some tips that I will give you guys from my experience as to how you can really approach the problem well. It's number one, listen carefully to the interviewer. The interviewer will emphasize important parts of the problem. So if a lot of people are like messing up in past interviews, or it's a place that can cause a lot of confusion, they'll emphasize this. So make sure you pay attention. And right after they tell you the problem, make sure to rephrase the problem back to them, and so that you can make sure you understand it. If you're having trouble understanding, you can definitely ask for clarification or another example. They're happy to give it to you. And this will in no way, shape, or form tell them that you're not a good programmer. They might just be a little bit confusing, or that problem may be something that you've just never come across before. And also ask about edge cases and special cases. This is very important when you're programming. You don't want to miss that one edge case and then have everything else be perfect code. That's just not what we want, especially because these are very simple things that you can just add on and make really good. So clarify the range of inputs and outputs. Are you going to have any nulls? Can it be 0 coming in? Can it be like 999? How about 1,000,000? How about 10 million? Are you going to go above the integer value? Like, what exactly do we need? And then null values are also a special common case that, special case that comes up very frequently in problems as well. And take your time. So when you're starting out with these interviews, it's very easy to be like, oh my God, they're waiting on me. Oh my God, like I have to say something right now. You can take like 10, 20 seconds just to like run through the problem in your head once and just get a game plan going. So you're not completely lost when you start talking. Just have that like brief, I'm gonna say this in the first 2 minutes at least, just like keep going from there. And before you start, just form that game plan. Talk through out the whole process of forming an algorithm and finding the space and time complexity, which I will touch on. So make sure to talk through everything. Start with the brute force solution and then work your way towards optimizations, and only if you can. But talk through everything. So this is what I want to start off with at first glance. This is what I see. This is what I understand. These are the data structures I'm thinking about right now. And then as you go on, you can refine these thoughts and change them however you want. And one thing I've seen people trip up on is making a mistake. If you make a mistake, it's a-okay. The worst thing you can do after you make a mistake is use that to do bad on the rest of the problem. You can definitely recover from this mistake, change it up, make sure to vocalize finding the mistake and then fixing the mistake as well. So talk about why that's incorrect and how you can fix it. So one thing I will touch on for essentially the rest of this section is Big O notation. I know there's a lot of confusion about what Big O is, what is time complexity, what is base complexity, and why do we need it? So you're going to be asked about big O notation for every single problem. We'll show you guys how I'll ask that and how Katie will respond to that at the end when we do our mock interview. But it will be asked, and companies want to see the best solution, but more than that, they want to see that you can understand your algorithm. And the way you can show them you understand the algorithm is by putting it in big O notation and showing them that you know how your algorithm runs, and for a big N, for a big input, how your algorithm runs. And when you practice, make sure to analyze your own solution. So when you're doing these LeetCode problems, yes, you can do the solution, you can get everything, it's like perfect. But if you don't know the big O of that, there's really no point. Like, no matter how good of a coder you are, you really want to make sure you understand how your algorithm runs. So the first is time complexity, and time complexity is measuring the time your program takes in terms of the input size. So if you have an array of 10, how does your program run based off of that? If you have an array of size 100, how does your program react based off of that? And it's all in comparison to the input size. And we take time complexity instead of time because machines can record different times for the same piece of code, depending on what other softwares they're running at that time, depending on what other things are just going on with the machine. If the machine's older, maybe it runs code slower, just general things like that. And different languages and libraries vary in time for the same algorithm. I stated before that hash tables have overhead because of multi-threading. So a lot of people use HashMap because of that, just because hash table and hash map are essentially the same thing. It's just that synchronization aspect that's just different. So even though the algorithm runs the same exact way logic wise, it's going to take longer if you use hash table for that reason. And space complexity is just measuring the additional space in memory that your algorithm takes. And the keyword here is additional. We don't want to count the input size as a part of our space complexity. They'll give us something, and that's not the memory that we're purposefully adding on as a result of our algorithm, so we don't have to include that. And why can't we rely on space alone? And that's because of language overhead. This is just one of many reasons, but this is the primary reason. Some languages will record things for some data structures that other languages will not need. So an example, we can take the time complexity and space complexity of this. So this is a very simple function, and essentially we're getting passed in an input array, and we want to multiply every single element in this input array by m and then return that. So first we're going to create a new array of the same size, and we'll call this size n, which is the size of our input array as well. And for each I in the input array, we want to assign the element where I is in the new array to the input array multiplied by m. So we're just sticking in the value at location I multiplied by m. We're just multiplying it by that one number. And then we're returning the new array. So in this function, we see that we create a new array of size n. And so that's going to contribute towards space complexity. We're going to say, okay, so the bigger our input array gets, the bigger our array gets. So this is a linear relationship. So we can say that we create O of n space, or just n space. And we also have to make sure when we're doing space complexity and not the big O version, that I is also a variable. So it'd be n plus 1, because when we have a for loop and we're iterating through that, we have to create I as a new variable. So that's n plus 1 space complexity. And for time complexity, this is a little bit more complex. If we look here, we have one initialization, and within the for loop, we have 3 parts that are going on. We have one initialization, we have a comparator, and we also have an incrementation and an assignment. So these 3 things, plus inside of the for loop, we have another assignment and then an arithmetic, and then we have a return statement. So we can see that this gets out of hand very, very fast, especially if we have to calculate it for 100 elements, for 10,000 elements, or maybe even 10 million elements. This is going to take a little bit of time. So as a result, we have Big O, yay. So Big O to the rescue. So now we can just generalize all of these. And instead of giving a specific time complexity and a space complexity, we just give them the upper bound, the worst case. And you really will not be asked about the specific time complexity of code in your interview. It's mostly just going to be Big O. That's all they're looking for. And Big O essentially just quantifies the performance of the input size, or of the function, as the input size becomes large. And it lets us compare different algorithms. And Big O can also have multiple variables. So if you have an input of, or if you have 2 inputs of varying size, so one of size m and one of size n, your Big O can be in terms of that. And we also see big theta and big omega right here. They're not widely used, but it's just good to know them. Big omega is the notation for the best case for a given function, and big theta is the notation for the average case. So a really good example of this is quicksort. It's an n log n sort on an average case, but in worst case, it can be O of n squared, and the best case is also n log n. So that's one algorithm that is very common to see different average cases, worst cases, and best cases of. So for this example, we can see the big O. We'll just try to calculate it real quick. So the one on the left, we can see that this one has an assignment, which really doesn't matter in big O notation. And then we have a for loop that goes from 0 to the number. And that for loop is going to be, that's going to take num times. That's going to take num times. And then for each thing inside of the for loop, we have an assignment and an arithmetic, which really doesn't matter because we're doing big O. And then we just have a return statement. So overall, in this algorithm, we see that as n increases, the time our algorithm takes also increases. This is a linear comparison. So instead of having to calculate each assignment, each arithmetic, and every little thing inside of this algorithm, we can just say it's O of n time, because that is the upper bound and it's the generalized version of the time complexity. And for the space complexity, we see that we're not really creating anything except for I and also total. So because of those two things, it's just constant time. And instead of putting 2, we can just put 1 because it is a generalization. And on the right side, we see a better version of the same exact algorithm. So it's add up to num. And in this case, we're just using a formula. And this should say O of 1 when space complexity. I'm not quite sure why that's there. And in fact, we create no space in this scenario. We just use exactly what our input size is. And so it's an O of 1 solution because we don't have any for loops here and everything is just constant time, no matter how big num is.
Yeah, so now I'm going to go into a quick interview breakdown, and then we're going to do the mock interview, showing off like what it should look like. But first, I want to kind of go over what you can expect from an interview, especially if you haven't done one before and you don't know what to expect. It can be super intimidating, especially you hear all these things about, Big O and like knowing all these algorithms, but like what is actually going to happen during your interview? So there's definitely no like one size fits all for companies. It's going to vary a lot. I would say in my experience, what seems to be the kind of standard has been like what's on the left here. So you usually have like 5 minutes to introduce yourself, and then you have 30 to 45 minutes for a coding question or coding questions, plural. Sometimes they'll give you multiple, and then 5 minutes for questions. And then some companies will give you multiple questions in the time. Like I know Facebook is one that does this. So Facebook gives you 2 coding questions in like 45 minutes. And like other companies do that too, but I would say it's much more common to only have like 1 question with maybe some follow-ups like attached to it. But you can see 2 questions in one round and in those cases, you really have to be prepared to, think quickly and like get a solution. Doesn't have to be perfect, but just like get a solution in that time frame. But yeah, you can expect different things. I always recommend researching the company beforehand so you know what to expect, or even asking your recruiter what you can expect from the interview, because they'll usually at least give you an overview. And then to go a little bit more in depth, so again, those first 5 minutes, the interviewer always introduces themselves. I know for me, I tend to like, I'm always super nervous at this point, right? So I always like tend to zone out when the interviewer's talking, but like that's bad. Like I try to force myself to like pay attention to what their introduction, because like sometimes they're doing really cool work at their company and I want to ask them about that later. So like I maybe that's just me, but like I'm always just like thinking about like coding and like it's hard for me to like relax, like listen to their introduction, but I need to. And then you're also going to introduce yourself. So this is the time where you give your short little elevator pitch, um, which I'm sure you guys have heard that phrase before, but just giving like your name, like what school you go to, what you're studying, maybe what clubs you're involved in, and things like that, which is, I mean, kind of go based on how long they introduce themselves for, but if they like just say their name, then like you just say your name, but you can kind of base it off of them. And then use this time to just kind of relax, like take, breathe a little bit. The introduction is always nice because you don't have to like start coding right away. And then you'll get the coding question. So, and we kind of like talked about this already, so I'm not going to go too in depth, but like we said earlier, you're going to want to clarify the problem before you start coding. So make sure you heard it right, make sure you ask any of those clarifying questions and questions about edge cases. One other question I always like to ask is if I should optimize for time or space complexity. so you kind of know like what they're looking for in their solution. But yeah, this is the time to just like clarify everything, make sure you're understanding. Um, Another thing I like to do is like actually like they'll usually give you like sample input and sample output, but if they don't, maybe I would come up with one. So if they gave me an algorithm, I'd say, okay, so if this was given 10, like it returned 15. Like you just really want to make sure you're understanding what this function is supposed to do. And then you're going to have like, so after you kind of clarify everything, that's when you're going to want to start developing your algorithm. And again, do not start coding before you have your algorithm. Like it's a bad idea because you're going to start coding and realize what you've been doing is wrong and have to backspace everything and waste a lot of time. So you're going to just want to verbally talk through the algorithm you're thinking. You're going to want to talk about the data structures you're going to use, whether that's a hash map or a linked list, whatever. Um, and you're going to want to consider trade-offs of every decision you make. So if you do decide to use an array over a hash map, like explain why. Like you could say, if I use an array, it'd be easier because everything's ordered. But if I use a hash map, then I can access everything in constant time complexity. So you want to like talk through all of that with the interviewer. You don't want to any thought that goes through your head, like you pretty much want to say, because that helps them see kind of what you're doing. So once you kind of decide in the algorithm, like walk the interviewer through it, you say, okay, I think what I'm going to do is, well, I'll show you this like when we do our demo, but you tell them what you're going to do. And usually if you're on the wrong track, the interviewer is going to give you hints. Don't get like defensive. Don't think they're just trying to judge you. Like they're trying to help you. Like if they tell you like, hey, why don't you do this? That's usually them telling you, do this. Because they want to see you get this problem. They aren't there to like get you, but like sometimes they'll like kind of very subtly hint you towards the right place. So like be very aware of what they say to you. Okay, so here's the fun part, actually coding your solution. And yeah, if you've already thought through your algorithm, this part is going to be easy. And you might have to make changes to your approach like as you code and realize, oh, actually this isn't going to work. But hopefully you don't have to make too many like large changes. And obviously if you do make changes, make sure the interviewer knows. Practice good programming practice. Even if your syntax like isn't perfect because of like the time limits, you still want it to like show that you know how to program well. You don't have to like leave comments or anything like that because again, the time limits are usually pretty tight, but you do want to have good variable names, make it easier to read for the interviewer because if you start using like a bunch of if loops, they aren't going to be able to read it and they won't know if you're right. And yeah, like I said earlier, like some companies actually will run your code and others just like don't care. Um, yeah, like I had one interview where I couldn't move on to the next question until my code compiled and ran correctly, which is like super frustrating because like I had like some syntax errors. I was like, trying to fix them. But then some companies will literally like turn off the compiler and it's like super nice. So it really varies. And then once you've actually implemented all of your code, you're going to want to test it. And this doesn't just mean like running the code to test it. This means like actually walking through it like line by line with a sample. And again, especially if you don't have a compiler or a way to run test cases, you're going to want to do this. So yeah, I usually like to use the sample input they gave me to start and then like go through each line, like say, okay, at this step, this is going to happen, and make sure you get the output you're expecting. And if you're able to compile it, you can run different test cases. This is also when you'd want to test out your edge cases. Um, yeah, and when you find mistakes, which I feel like you usually will find something, you want to fix them. And then at the very end is when you do your analysis of time and space complexity. Again, like go through line by line, look at any loops, and consider those time complexities. Also think about things that might be happening that you don't see. Like for example, if you call a sorting algorithm, like if you like Java and Python both have this, where you can call like dot sort for an array. If you use that, it's not happening in constant time, even though it's only one line. It's happening in like n log n time. So you need to be aware of things like that because I feel like that's a very easy way to trip up on the time complexity analysis. Discuss how you want to optimize the code if you have more time. Like you don't always have time to optimize, but if you do, you can code it then. The interviewer will kind of tell you whether or not they want you to like actually write out any optimizations. And the interviewer will generally ask you like lots of questions about your code, like if they notice an edge case that you didn't, they'll ask you about that. So just be prepared for those questions. Definitely don't get defensive. Like they're not trying to just like criticize your code. Like this isn't optimized enough. They're trying to just see your thought process and see if you can think about optimizing in the future. Again, it's not, so like don't stress out if you realize, oh no, my code wasn't optimal, because they aren't expecting perfection, but make sure you do address any of those questions at the end. And then I'd say pretty much every interview I've had, you've had time to ask questions at the end. Always have some questions like written down. It's going to be really awkward if they say like, do you have any questions for me? And you're like, nope, I'm good. Because that doesn't show you have an interest in the company. And they generally like talking about their work. So you definitely don't have questions. And you might think that you'll be able to come up with some on the spot. But I know for me, like I need to have some things there just in case my mind blanks. And yeah, if you have any specific questions about the company or the role, you can ask. And yeah, try to show you have an interest in the company and you've like, thought about working there. Here are just like a few examples, but anything you're interested in would be good. I would say try not to be like too generic with your questions. Like you want to have good questions that like have interesting answers, but yeah, that's just always something you want to think about before your interview as well. Cool. So now we're going to go into the mock interview, and we're going to use a website called CoderPad. So this is what's, wait, I have this pulled up on another. I'm going to stop sharing for a second and share my other screen. Okay. Cool. So CoderPad is used by a lot of companies. I've used it a lot this time. Facebook uses CoderPad. Like a lot of companies I've interviewed with do, so that's why we're also using it, so you can kind of see what it looks like. I'm going to use Python, like I talked about. I'm a Python person, so I'm just going to start a sandbox. Which, wait, I don't know. Hang on. I think it's because I did this the other day. I'll just make. Hopefully, it works on a computer mode. Okay, cool. Yeah, so this is usually what you'll see like when you log into like any company. So, okay, cool. And then, and you're gonna have like your interviewer will be able to share the same screen. So in this mock interview, I'm gonna be the interviewee, and Alarica is gonna be the interviewer. So if you want to join this too, I just slacked you the link so you can give me my coding problem.
Okay, perfect. I should be in.
Yeah, so
I don't think we see the actual sandbox on your screen.
Oh, okay.
But are those changes showing up?
Yes,
as you can see, I'm typing, but yeah, that's showing up.
And
so I'm gonna get rid of this.
Yeah, so this is again what you're gonna expect to see in an interview. It's like it looks like an IDE, but it's in your browser. And some features, like sometimes you'll have this option to run your code, sometimes you won't, it depends on the company, like I've talked about. You also usually have access like a whiteboard if you want to like draw any diagrams for your solution. But that's again like not very, I don't know, I never really do that, but that's always an option too.
Okay, perfect. So hi, Katie. Thank you so much for joining me today. So I'm Alarica, yada yada. My company is XYZ, and I'm so happy to have you here. So tell me a little about yourself.
Hi, I'm Katie. I'm a computer science major at UT Dallas. UTD, I'm really involved with the Society of Women Engineers. I'm vice president there. I'm also involved with the Association for Computing Machinery, but very excited to interview today.
Love that. Okay, so because we're on a little bit of a time crunch, I'm going to go ahead and give you your first problem. I'm going to paste it in here. Let me know if you can see it.
Yeah, I can.
Okay, so today our problem is called first unique character in a string. And so given a string, which would be your input, find the first non-repeating character in it and return its index. If it doesn't exist, return -1. So let me give you an example just to make this a little bit more clearer. So if we have the string hello, we can see that we have 3 unique characters here. We have H, E, and O. But because H is the first unique character, we want to return its index, which is 0. So you would just return 0 in this case. And another example to make this extra clear is also here. So we have a string ADDA, DDA. So in this string, we see that we have no unique characters. Every single character repeats, and that's just A and D. So it'll return -1.
Okay. Yeah, so when you say characters, can it also include things like numbers and spaces in the input?
So you may assume that all of the strings are just going to be all lowercase letters.
Okay. Okay. So I'm just going to make sure I understand and like do another test case. So yeah, so the
Hmm.
reason so the output, wait, this is supposed to be H, right? Not 0. I'm not sure.
So we are returning the index in this case,
Oh,
so we
right.
will
Okay.
return 0.
Yes, returning the index. Yes. Okay. Okay, that makes sense. Yeah, so let me just make sure I understand by doing one more. So if I had
For
something
sure.
that looked like this, I'd be returning E, so I'd be returning 2 instead because E is the
Yes.
first one. Okay. Okay.
Yeah.
And I can assume that it's all lowercase letters.
Mhm.
Hmm. Okay, I think I understand this problem now. Would you say that when I develop the solution, should I focus on optimizing for the time complexity or the space complexity?
First, I would love you to just get a solution on here. Don't worry about this time and space complexity. And from there, we can try to optimize on time. But I would love for you to just work on whatever comes to mind right now.
Okay. Okay. So my first solution, I guess kind of the brute force solution that first comes to my head would be if I go through here and just iterate through the string. And when I come to this first character, I search the rest of the string and see if it appears anywhere else. And if it doesn't appear anywhere else, I know that I return that index. Um,
Okay, nice. So could you walk me through that logic using the first string that we have here?
Yeah, sure. So I would start here, index 0, and I have the character H. So then I would go through the rest of the string, and I go to E, then I go to L, and then O, and I don't see H anywhere else in the string. So I know that it's the first unique character because I'm iterating through the string in order. So I know to return index 0.
Mm-hmm. Perfect. Yeah, that sounds good. So that definitely works. And I really like that you're thinking about the brute force solution. Do you think that you might be able to think of a solution that doesn't require going through the whole string every single time? I would also like to ask you, what is the time complexity of the brute force solution that you just told me?
Yeah, so the time complexity, if I'm having to iterate through the whole string, and every time I do that, I have to iterate through the whole string again, that would be O of n squared, where n is the length of the string. So for large inputs, for long strings, that's going to have a really bad runtime. So I think you're right that I can think of a better solution. Um, One thing I'm thinking is if I were to iterate through this whole string just one time at the beginning, and I keep track of which of the characters are unique in that first iteration. Then I iterate through it again and then reference whatever I use to store that. Um, and so that way I don't have to iterate through everything each time. I'm just trying to think of what data structure I would want to use for that. Um, I guess one option I would have would be to use an array where the index of the array is the character, because like you said, I'd only have to consider the lowercase letters. So if I said like indexes like 0 through 26, I could store like true or false in those arrays. And that would be a nice solution because I could access that value in the array. Um, but I guess the negative with that solution is like in this one, I'm only using 4 different letters. So I'd have to have an array of size 26 and I only need to access 4. So another option I thought of would be using a hash map, where the key of the hash map is the
Hmm.
actual letter and the value stored in that hash map is the frequency. Um, so then I can iterate through this, and every time I come across a new letter that's not already in the hash map, I can add it, and I can increment like the frequency by 1, and then I do that, so I make one pass through the string, so like a loop with n iterations. And then the second time, I iterate through this whole string again, and each time I'm referencing that hash map I made. So I come to H and I reference the hash map and see that it's only occurred one time. So then I can um, like the same logic in my previous one where I know it's the first original character, or the first unique character, but I didn't have to go through everything again because I was able to access its frequency in constant time. So, what do you think of that solution?
So I really like where you're going. I think this is a more efficient solution than the first solution you did give me. How exactly would you find out what you have to return, what index you have to return from this hash map you say?
Yeah, so the first iteration I make through the string is when I'm adding to the hash map. And then I'm going to iterate through this string one more time. So I'm going to keep track of the index as I make that iteration. So like I'll go through and like when I'll have an index variable and I'll start at 0. And so I'm right here. I know the first character in the string is H. So then I would reference my hash map and pull the frequency out. And if the frequency equals 1, then I know it's unique. So then I can return the index I'm currently at.
Okay, sweet. I think you have a good solution down. I just want you to consider any edge cases that might be involved if your algorithm works in that case as well. So can you think of any edge cases, any special cases that you might have to consider?
Well, I definitely need to consider the empty string. So if a string is empty, I just need to return -1. I think that could be done with a simple if loop at the beginning. But the reason that'd be an edge case is because if I tried to iterate through the strings and add to the hash map, there's nothing there, so that wouldn't work. In terms of other edge cases, I think the nice thing about this solution is I wouldn't have to worry about if other characters occurred or do I have to worry about any other characters being in the input, like making sure they're not lowercase letters or
We can assume that all of the characters are lowercase, so we don't
okay.
have to take away anything else.
Yeah, I would say the one other thing I have to consider is that at the very end, if I make it through that entire for loop, I need to return -1 because if I make it past that for loop, I know that there hasn't been any unique characters. So I think
Perfect.
doing that would take care of all of the edge cases.
Sounds good. So now that you have a perfect logic, and I love how you've taken care of all the edge cases, we can start coding.
Okay, and do we want it? I'm not sure if we want to move to the Q&A or if I should like actually like.
Just give us a brief overview of
Okay,
the
okay,
logic. I think we should be fine. Don't worry about syntax or anything. You can
all right.
make it all pseudocode.
Okay, cool. So this is my frequency hash maps. This is what I'm going to use to store all of those frequencies we discussed. So I'm going to start by making my first pass through the string, and I'm going to see if the letter's already in the frequencies, and if it is already, I'm going to, or I guess really one way to optimize this, I don't really need to store the frequencies. I just need to store whether or not it's unique or not. So I could actually make this a little bit simpler. So if it's already in the hash map, I know that it's not unique. So I can just set this equal to false. And then for its first occurrence, I'll set it to true because if it's not already in the unique hash map, then I know it hasn't occurred yet. So far it's unique, but the first time I find it for the second time, it's not going to be unique anymore. So that's one way I can just make it a little more efficient. So now I'm actually going to iterate through this string again. And this time I need to keep track of like the index. That's why I use the X instead of just the simple Python syntax. So now I'm going to see if unique, if that character is unique, I am going to return it because it's the first unique character. So I will return, or I'm going to return this index. And then if it's not, I'm just going to keep going. And if I get to the very end and nothing's been returned, I'm going to return -1.
Okay, sounds good. So I don't see any flaws in your logic. And if we had more time, I would ask Katie to go through one of the examples with this algorithm, but we can definitely move on to Q&A. I think you've done a great job. Yeah.
All right. Cool. Let me go back to the slideshow real quick. Or do we have, I don't think we really have anything. So yeah, if anyone has any questions, feel free to drop them in the chat.
If we get blindsided by a technical question, that's actually a very valid point. Your interviewer will definitely help you. They're definitely there just to aid you along the process. So if they see that you're getting a little bit lost or you don't know where to start, they'll give you clues. Just make sure you listen carefully and you'll definitely catch them.
Yeah. And like again, even if it's like the worst solution like in history, if it has like O of like, or if it's gonna be like the runtime is like O of n to the fifth
Factorial.
power, yeah, O of n factorial, like try and just think of something like brute force. Yeah, and like I kind of showed that like in that solution, like I feel like I feel like a lot of problems have some kind of brute force, and they'll at least get to see that you're thinking. But it's definitely a lot of it comes with practice too. I feel like not freezing up and things like that. Um, how did I learn Python so quickly? Yeah, one thing I did was actually I found like a Python cheat sheet with like all of the syntax. And I like wrote that out and like copied it down. So like I have it on my desk. It's actually like over there, but I have that like and writing everything out helped me, and I learned a lot about Python as I did that. And then I've done a lot of leak coding, which helped kind of solidify everything. And actually, that reminds me, we did have this slide about additional resources. So real quick, if you do want to learn more, oh yeah, what kind of practice do we do? I know for me, I read Cracking the Coding Interview this summer, which is like everyone always talks about this book. So I was like, okay, I have to read it. And it's definitely really good for teaching you all of the fundamentals. They have like chapters about like a chapter about linked lists, a chapter about binary trees. It's like everything you need to know. And they have lots of practice problems as well. And then Leak Code is amazing because it's lots of practice problems, and they also have company-wise problems. So if you're interviewing at a company, you can see like the most asked questions at that company. And that's like technically Leak Code Premium, but there are ways to find those companies for free. So on like you can find things through Google. Then Alarica, you can talk about ACM's interview prep workshops.
Yeah, for sure. So my first introduction to really a lot of the popular data structures was through interview prep workshops last semester. ACM Education has a great series of workshops. It's not there anymore for this semester, but they will be back next semester. So be on the lookout. That really taught me a lot of the common algorithms that are used in interviews and how to just get used to a lot of the data structures that are used as well. And I also did a lot of leak code. I was late for the interview grind for the season, but I definitely did a lot of leak code in the time that I was preparing. So that definitely helped me a lot.
Yeah. And the last thing is just mock interviews are like so helpful because like I'm sure as you like saw in our demo, like you kind of have to learn to like talk in a different way. Like you kind of need that like interview voice and like, yeah, I see that approach. And yeah, I think that like I don't know, I feel like practicing is like the most important thing you can do. And you can practicing coding all you want. You can practice coding all you want, but if you aren't practicing like actually explaining your logic out loud, you're just gonna sound like hash map like it won't go well. So highly recommend, even if it's just alone and you're just coding and talking to yourself, like it will help, I promise. But the best thing you can do is mock interviews with friends. There's a website called Pramp that will actually like connect you with people to do live interviews. I've never used it, but I've heard good things about it. So if you, that's another. Yeah, I'm kind of scared of it too. Like I don't want to code with strangers, but I've seen it recommended a bunch. I would recommend finding friends though, because then it makes it more fun. You can kind of like make fun of each other, you know, and it gives you that same experience. But like, I mean, like what I just did, like things like that, like are just so helpful in like actually practicing speaking and things like that.
I think talking through your approach really looks easier than it is. I remember when I first talked through my approach for the first time, I was like, wow, I wasn't expecting that. I thought I would do better. I thought I wouldn't trip up as much. So make sure you definitely know how to vocalize your thoughts before you go into your first technical interview because you will be caught off guard.
Absolutely. And that combined with like the nerves too. If you've
Oh,
never done it
yeah.
before, you're nervous. Like literally, I feel like my first coding interview, oh my gosh, like I couldn't even like just try and think of syntax. Like your brain just stops working. And I guess one other strategy I kind of have is like if I do something stupid, which like I do a lot in coding interviews, like I had an interview where I forgot how to like I wrote the code and then he's like, okay, can you like write a test case to test your code? Like he was actually like compiling it and he wanted me to just like so like the input was a list of integers and I forgot how to like this is back when I used Java still. I like forgot how to initialize a Java list like with like I could only think of like how to do it, like where you create a list and then add things. I was like, wait, how do I initialize like a list of integers, like hard coding the integers in? And he's like, I think you're supposed to use curly braces there, because I'd used like the wrong braces. And I was like, oh yeah, like I don't know, I kind of like laugh at myself a little bit. Like, I don't know, I try not to get too like defensive or anything, because then you kind of like, I don't know, and yeah, that's why I say use Python. But like if you do something stupid, like don't take it like don't freak out. Like you want to stay calm. Like that's the most important thing. Like if you get flustered, you're going to like once you make one mistake, if you let that fluster you, it's just going to go downhill. Like you have to like learn to like you made a mistake. It's like okay, everyone makes mistakes. Like you can make a little joke if you want, but don't like let that affect the rest of your performance, because I really don't think they judge you for that. 'Cause I've definitely made lots of dumb mistakes in like I don't know. I think the nerves, like you think you can do syntax perfectly, then you get there and you're like, how do I
Yeah.
code? But don't let that fluster you.
Definitely. I completely agree. Mistakes are very easily redeemable in coding interviews, especially. I think even if you do okay on one problem, if you like blow it out of the water with the next one, like you're gonna remember the next one. They're barely gonna remember the first problem. So as long as you redeem yourself and show that you have improvement as the interview goes on, you should be good.
Mhm. Yeah. Yeah, and then one other thing I want to plug real quick. So we also have on this Wednesday we have how to ace your behavioral interview. So today we covered technical interviews, but you also are going to face behavioral interviews. And this is like hosted by Women in Technology and Business and SWE. And this is going to be really cool because we're going to actually go into breakout rooms and you'll get to answer sample behavioral interview questions. So this is another great workshop coming up. So if you want to get practice with technical and then behavioral, you should definitely show up. But if there are no other questions, it's 8 o'clock, so I'll stick around if anyone else has anything.
I see someone asked what an array was. So essentially, an array is an indexed list of just any element, can be of any object, anything. Key is that it's indexed. Yeah, thank you so much for attending, guys.
Yep. Hope it helps. And good luck on all of your interviews, guys.
Yes, good luck. Y'all got this.
Yeah. The secret word is internship. Thanks, Christina.
We're
Oh, good
kidding.
luck,
Okay.
Abigail.
Yeah, good
That's
luck. You
exciting.
got this. Just be confident.
Yes, yes, absolutely. Even if you don't know what you're doing, if you pretend you do.
You got it. Yes.
And I will stop the recording.